Hey guys, this is Coach Lowe and this is Contextual Geometry. We are in Chapter 10, Section 2, and we are going to talk about diagonals and angle measures. So we are in the chapter on polygons, and so as we continue our discussion throughout this chapter, we'll talk about different pieces that go along with polygons. And so today we're going to talk about how to find the measure of interior angles, the sum of the measures of interior angles, and also exterior angles, and then talking about diagonals of polygons. All right, so we'll do an activity in class, which will be kind of fun. But for now, we are going to talk about some theorems. Theorem 10.1 says, in a convex polygon, so remember, convex polygon means it doesn't have any sides that look like they've been punched in. Every diagonal that I draw will stay inside the figure. All right, so if a convex polygon has any number of sides, or so n sides, convex polygon have at least 3 sides, then the sum, so adding up all of the measures of the interior angles, is n minus 2 times 180. All right, so let's talk about why that works that way. All right, so first of all, let's start with a quadrilateral. All right, in a quadrilateral, I can draw one diagonal, and it doesn't really matter where you draw it from, but I draw one diagonal, and I know the angles in this triangle, they're not equal to each other, but these angles add to be 180 degrees. I know the angles on the inside of this triangle add to be 180 degrees. So these two triangles put together will be how much? 360 degrees. 180 plus 180 is 360. Now, we don't necessarily want to draw figures every single time to figure out the interior angle measures. We could, but we have this formula here that will help us. So you plug the number of sides in for the polygon for n, subtract 2, multiply by 180, and bam, got it. All right, so I see number of sides here is 4. So 4 minus 2 times 180 is the same as 2 times 180, which is 360 degrees. It's exactly what I found here drawing the picture. So yes, you could draw the picture every time, but if you're given a number of sides, let's say we have a 13-sided figure, so a 13gon. 13-sided figure, I really don't want to draw the picture, draw 13 sides, draw the number of diagonals, count them, or count the number of degrees in each triangle. I really don't want to do that, and there's really no need to do that because we can use this formula n minus 2 times 180, and we are going to plug in 13 for n. All right, so notice order of operations here. I have to subtract 2 from 13 first and then multiply it by 180. Let's get the little calculator out here. Not that you guys would do that. I'm totally not saying that. So 1980. By the way, shortcut, mental math part, is 10 times 180 plus 1 times 180. 10 times 180 is 1800 plus 180 is 1980. So just some mental math, free today only. Just kidding, it's always free. All right, so you can tell me the sum of the interior angles. It doesn't matter what type of or how many sides I give you. It has to be a convex polygon. You can do that. That's awesome. Okay, so let's talk about also, how about exterior angles? Let's talk about those. All right, so theorem 10.2, exterior angles. So 10-1, interior angle theorem, 10-2, exterior angle theorem. In any convex polygon, the sum of the measures of the exterior angles is 360 degrees. Doesn't matter the number of sides. Makes absolutely no difference. The sum of the measure of the exterior angles is 360 degrees. All right, so let's say that we have a octagon. All right, sum of the measure of exterior angles. Don't even have to do any figuring. 360 degrees. What if I want the measure of one exterior angle? How many exterior angles would I have in an octagon? Yeah, 8, right? I have 8 interior, I would have 8 exterior. Now, when we draw an exterior angle, so there's part of my octagon. When I draw this exterior angle, here's what it looks like. You can just drag a side out and there's the exterior angle. So that's what I'm wanting. What's the measure of that one angle? Well, 360 degrees. There are 8 of those angles. So 360 divided by 8 is 45 degrees. So this angle is a 45-degree angle. All right, so if they want one angle, divide by the number of sides. Would that be true for interior? Let's back up to interior. What if I wanted the measure, so this was the sum. What if I wanted one interior angle? Then I could take the sum and divide it by the number of sides. So, back to handy dandy calculator, 1980 divided by 13, 152.3. All right. So we know how to find the sum of the interior angles. We know how to find the measure of one interior angle in a convex polygon. A regular, this would be regular, like all the angles are the same measure. We know how to find the sum of exterior angles, 360 degrees. We don't have to do any work. And if it's a regular octagon, then I know how to find a single exterior angle on a regular octagon. Now remember, when we're talking about regular polygons, that means all angles are the same measure, all sides are the same length. They don't always have to be. So watch the instructions and make sure that that's what it says. So like on this octagon, it would say find the measure of one exterior angle of a regular octagon. So that would be the key word there. All right, guys, that's it for today. See you soon. This is Coach Lowe, and I'm out.